So the mutation testing is going to be presented by Vikhyath, a thought worker. So to tell a brief about Vikhyath, he's 6 years experienced in agile methodologies, who has explored in varieties of domains such as banking, retails, and health across mobile, web, and data platforms. So he's also has an experience in Java, R, and Android, and he has done a many lot of contributions to C and Golang communities. So yeah. So we are very happy to have you, Vikhyath. So over to you.
Vicky, you're on mute. It's always good to see Vicky's happy face.
Yeah.
Okay, thanks for the warm welcome. So, am I audible here?
Yep, loud and clear.
Awesome. All right. So quickly, let me share my screen. Is my screen visible?
Yes, Vicky.
Yes, Vicky.
All right. Yeah. So yes, I am Vikhyath. I'm a senior consultant developer at Thoughtworks. So today I'm going to give a brief introduction on what is mutation testing and how it's going to work in your project day-to-day basis. So let's get started on that. So before starting, there's this URL which I'm sharing on screen. If you have any questions over there, you can ask in the URL so that I will be able to present to other audience as well. And do stop me if you have any questions. Other panelists like Shakti and Monica, please help me out if there are any questions out there.
Sure.
In Zoom chats or YouTube. All right. So getting started with this, right? So this is my favorite topic now. So I've learned, like I got to know this a couple of months back, and now I've been like promoting this everywhere I possible. So that this is so awesome tool. I liked it that much. So let's get into it, like what it is. So before I start, before getting into what is mutation testing, let's try to understand what do we have in a software testing. What does it look like, right? So general software testing parameter looks something like this, wherein we have 70 to 80% of layer as a unit test layer, where we cover most of the functionalities, major functionalities with proper test coverage, unit test coverage. And then on top of it, we have service layer and the UI layer. So as you see, even here, as the arrow mark relies, the unit test runs faster and costs less. And the way it goes up and up the next layers, it runs a bit slow and it costs higher because any bugs caught in the unit layer is much more faster and reliable rather than catching it in at the UI layer. Of course, catching at the UI layer is also safe rather than catching in production. But the faster you catch, the faster you fail, the faster you recover, right? So that's how it is. So how do we do that? So like this is now we are ready with it, right? So we have the testing parameter set up. Everything is ready. We know this is the plan. But how do we ensure that the quality of test is 100%, right? So I'm in this example, I am using Java as an language to demonstrate, but and also the tools which I'm showing is with Java, but of course there are a lot of other tools which are available for other platforms as well. Yeah. So having said that, ensuring the tests are sufficient.
Vicky, like once again, like Deva has posted that they're not able to see the presentation. Let's confirm with others before proceeding. Is that fine? Guys, if you're able to see the presentation, like kindly share yes. Cool. I think there's some issue with Deva. Like, can you rejoin it? Cool.
I will continue. Thanks.
Cool.
All right. So ensuring that the tests are sufficient, right? How do we ensure that? So in Java, generally there's a tool called Jacoco, right? Which we use to track the code coverage. And how this works, It's simple, right? Like the idea of this is simple. So you write the unit test, you have the source code. So it runs all the unit tests against your source code, and then it keep tracks at your source code, wherein each call which was made from the test to the source, it marks as the checked or unchecked. And if some line is not covered or not called from the test code, it is saying that you don't have this much lines of coverage. So this is done for each and every file in your project so that you cover each and every line of code. Generally, when you follow your TDD practice, right? So you do test-driven development, you write the test first, and then you write the code. Only related code that you wrote, like only relevant code you write for that particular piece of test, right? So in that way, it is avoided the, like we try to avoid the dead code and useless codes. But even after following TDD, based on the experience level, of course, TDD comes with the practice, right? So with the experience, this might also change. So if a newbie is coming, like a new developer is coming, they might be learning TDD for the first time, right? So it might be case that they might miss some cases, they might not do a proper TDD, and while the others may follow properly. And that is why we have these kind of tools which helps us to um, track all this. Even a newbie can easily track and take it forward. So this is happy, right? Though, like we have Jacoco here to cover, like say how many lines are covered in the code base branches. We are happy, all good. Okay, but the question is this enough? So since we are not live here, audience, so maybe you can type it yes, no, maybe in chats. I would like to be interactive session. All right. So yes, of course, yes. We see until now we feel that this is enough, right? So let's see going forward how mutation test comes in the picture and how it helps us. Let's see if this is really enough or we need some other tool to identify that. All right, so we'll just quickly run through 5 Ws and 1 H of mutation testing, and we'll see how things are taken forward from there, right? So what is mutation testing? Basically, it is just basically measuring of your measure the quality of your software tests themselves. So you write the source code, for that you write the test. But for that particular line of test which you write, how do you make sure that is a good quality of test, right? So that is what the mutation testing as a concept it is. So it basically does the same thing, like the software quality of your tests are tweaked out and measured using this tool. Why do we need this? Of course, to identify weekly tested pieces of your code and as well as of your test. That's the both ways. Also, the test code and source code both are tested and analyzed and shown a report to you, right? We'll see who and when together. So this was introduced by Richard Lipton in 1971, and then only after a decade, this came into an implementation by uh, Timothy Budd, right? Only after a decade of after a decade, the first implementation came in the picture. Why this didn't get very popular and at that point until till date is because this requires a lot of computational power to run this test. We'll see in a while why this takes a lot of time, a lot of computation power in a while. So we have spoken about what, why, when, who, and the last W is where, right? So let's look at again back to the test pyramid, which we just looked slides before. So we have the unit level, service level, and the UI level, right? Where does the mutation test plays in, right? So if you see there, it will be on top of mutation, like a mutation test will be on top of unit test and below the service level test. This is not a like total layer in itself. It's a very thin layer which just sits on top of the unit test. All right. Now that we have looked into the five W's, we look on the H, how part. So that's basically it's simple, right? So we know the Java, right? In Java, after we have compiled the code, it generates a bytecode, right? So what it does is basically take the bytecode and tries to modify the content in that bytecode, and then run your all your tests against that. So what happens is once I modify that and then run the tests against that, if all your tests fails, that means that you have covered your tests properly, because even after modifying modifying the source, the test should fail. That's why the tests are, right. We believe that is a backbone. And if that doesn't fail, if it passes, then it seems like your source is not totally covered. Either the test is improper or it is not covered properly, right? I'll stop here for any questions here. Any questions until now? People watching on YouTube also, you can also use the slides, this link to give ask questions. All right. If no questions, then I'll move on to the next one. Okay, now we know what is mutation testing, right? We have seen 5 Ws and 1 H of mutation testing. Next up is something which we will look into is what are the types of mutation testing, right? So here in this talk, I'm just going to cover three types of three types of mutation testing. There might be other things which are available in the market in different tools, but I'm going to talk about only these three things, right? The first one I'm going to talk about is the value mutation. What is value mutation? Value mutation is basically which changes the values of the constant to detect the errors, right? So we define many constants here. We define I equal to 0 or x equal to 0, and then we start from the loop. What if someone comes and changes the number tomorrow, right? Your test should be able to cover that and say that, hey, you have changed something, so maybe first add the test and then change the source code. So that's how it is. So the mutation, this tool helps us to do that. It is like a new week developer which comes and changes your source code randomly and then expects you to cover everything. And that's the beauty of this tool. And the second one is the decision mutation, wherein here we have many conditions, right? Like arithmetic and Boolean operators are there. Like we say when I equal to 2, then do this. Or when we say if it is Boolean or it is true, then do this. Something like that, if we do that, right? So what if someone comes and change I less than equal to 2 or something that like that. So this tool also targets such scenarios in source code and tries to change that, right? And the third one, which I'm going to talk about, is the statement mutation. The statement mutation is basically it will try to duplicate your statements or delete the statements. So some methods are void methods, right? In our system, like we just need to insert somewhere and we don't care about the output. We just have that void method. And what if that void method is removed or just duplicated twice? What happens then? Do we cover that enough in test? Of course, we have mechanisms to cover that, but have we covered properly in that test? That's the question. When that comes in, that's how the tools help. This tool helps us to identify these kind of statements as well. So all this is configurable. We'll see at the quick demo, and we'll discuss in deep data. Before I move to demo, any questions here again? Either the audience is very clear, like I'm very clear, or audience is not interested.
You're super clear.
Okay. All right. So let's go take a peek into the code live demo, how it works. All right. Okay. So in the demo, right, also when I mentioned we are going, like we follow TDD, right? So I'm going to follow the same TDD here. So we have this base class called Roman converter, which converts the Roman to Arabic numbers. So given an open string, it will give you the back in Arabic number. That's all. Simple code. Simple thing to do it, right? And then we'll start with writing some tests. For this demo, what I've done is I have written a couple of tests beforehand, so that we don't mess up writing, like waste time writing the whole of tests again. Let you go through the number of tests which we have, right? So we have for convert for 1, 2, 3, 4, 5, and etc. Until this, and I also have an error case scenario. All right. So what I've done is this. So let me just quickly do one thing before I move on. Okay. All right. So sorry, I did it. So here we have number of tests, right? Do you think these many tests are enough for covering before I write the code? Like I have these many tests to cover just the Roman numbers, major number of Roman digits. We have 1, 2, 3, 4, 5, and 10, and then it just keeps juggling on the numbers, right? So what happens when I run this test? Any idea? You can put in chats. I'll run this test. What will be the output? Panelists, you can also answer, by the way. Okay. So I'm just going to run this code for now.
So we got an answer. It should
Yes, what
pass.
is it?
What an answer from Deva.
It will pass. Okay, let's see, right? So 13 tests failed.
Okay.
Because I don't have any implementation, right? So I have written the tests, but there is no implementation. So obviously nothing will pass. Everything will fail. All right. So let me do one thing. So I'll just quickly go into stage 1, which has a basic implementation for that test which I have, right? So I've moved to stage 1. And I have a basic implementation of that. I have a static method which has static values of, if 1 is that, the numeric numbers for the thing. And then public method to convert the Roman into an integer. I have a pretty much basic logic, and nothing much, a pretty much simple logic. And then I have 2 private methods to just for extract out, right? So I'll just minimize this. So these are the methods which I have, and these are the tests I have. Now, if I run the test, what will happen? Okay, I'm just going to run the test. Let's see that for ourselves. Right. So now all the test cases have passed. Right. So let's look at the traditional level wherein we have Jacoco, right? We spoke about a tool called Jacoco, which did only the line code coverage. So I'm quickly going to open that up. So I'm going to go into build folder, the reports folder, Jacoco, and then I'm going to open the index.html. I'm going to open this in Firefox. Okay, so some are saying some tests may pass. Yeah, so now all the tests are passing since I have covered everything. Now all the tests are passing. I'm going to show you this output as well. What happened? So I have this, right? So if you see, this is the Jacoco code coverage report. This is my package, com.vikhyath is the package. And then I have this class. for Roman converter, right? And this is a static method which I have inside. So if you see the missed instruction and missed branches, I have covered everything, 100%. Nothing is uncovered. Everything I have covered here, right? So if I go inside, also look at the code, it will give you all the methods which are there inside. And once I click inside, it will actually show me the code line by line, right? So if you see everything which is in green color, it is covered. I have covered all the scenarios there. All right. Now this is fine. I am happy that like now as a developer, I have written the code, I have written my tests, I have written my code, I have covered 100%. In a better state, I'm leaving this. Now tomorrow, a fresh developer, new developer comes in, right from college, or a new graduate comes in, curious developer comes in, and then tries to do something. So now we have got one more input from the business to make changes in this. So instead of sending the values just like that, I want to validate this sum and then return. Just do some validations and then return. That is the ask. And this guy, the QS developer now, right, also does TDD. So they go here and then add new tests. So I am going to do the same thing. So now I am the curious developer here. No one is here. So I am going to do as this. I'm going to move to stage 2. Right? So this basically, if you see, this was the previous test. These are the two things which I have added now as a curious developer. And if you see the source code, again I have modified accordingly that to that. So before I was just returning sum. Now I have validating the sum and then returning. So I'm sending the sum as an input and then returning an output. If sum is less than or equal to 0, then I return -1 or else sum. That's my ask. The business has said to do this. And the curious developer comes and happily does this. Now, yes, also we have also given the instruction to the curious developer saying that, hey, we have this tool called Jacoco, run this, and if this gives 100%, we are happy that we are good. We have the total coverage there. We should be good. So the curious developer does the same, right? So I again go and run all the tests. What happens this time? Any guesses? No guesses? Okay. Sorry. Synoptic my system. All right. So now again, I run all the tests. Maybe I'll use the gradle to run test. That will give you a better visualization as well. Okay. I run via gradle. All right. All the tests passed right now. Right. 15 tests I've added and everything passed. So I'll quickly go to the report and try to refresh this page. Yeah, I have refreshed the page. If you see the validate method, this method also have come here. And it has given me all the reports that it has covered 100%. If I go back to this package, you see this says I have covered the 100% code coverage. It is done. Do you see a problem here in this code, this line of code? Do you see any problem? This line of code in test? Developer should write test cases for -7 errors. Yes, they should, of course. So I think they have invalid Roman values. They have written tests for that as well. Yes. That's true. We should start with, obviously, we should start with negative scenarios and then also start with one by one positive scenarios, step by step. You're right, Deva. Anyone else? Do you see any other problems here with the source or the test? If you want me to move here and there, let me know.
If Deva has posted something here, the developer should write test case for negative scenarios as well.
Yeah, I have attended that. Yeah, that question is
cool.
knowledge. All right. So in the interest of time, I'll let you know, right? So this happens. So whenever you code, right, this happens a lot of time with us, that we write these type of test cases. Do you see any problem in this type of test cases now? Yeah. So if you see this is just calling the method validate sum. This is not having any asserts in the statement test. This is basically a test without any asserts. And if I go and change any code here, like -100 also, still my test will pass because I have not done any assertion there, right? So I'm going to run the test and every test passes. Get the problem? So this is the magic. This is where the magic tool comes in. The mutation testing, right? Like we are going to use PIT for this particular demo in Java code base. I'm going to use PIT as a mutation testing tool and showcase you the demo. So I have already added the PIT coverage here, right? So I'm going to change this, okay? And I'm going to open the PIT coverage now. So I will just run test, which will automatically also run on the PIT coverage with it. So as it runs, I'll show you the output of that as well. So if you see here, the PIT test ran, and then it took all the test cases and then gave it to, it found 15 test cases and gave it to minions. And the minions went ahead and modified code here and there, and then it took 5 seconds to complete this. So it will be, let's have a look at the report, right? Yes, we can have a plugin. We can add plugin as a Gradle, Maven, also command line is available, Deva. I'll go through that for that setup. Also, I'll go through that in the after I'm done walking through the code. I'll also let you know the setup. Yeah. So I'm gonna open now PIT coverage, right? So this is the PIT. So I'm going to open the index.html and again the same browser. All right. So if you see this is combination of both, right? Like the line coverage is also there and the mutation coverage is there, right? So if you see, the line coverage is still 100% as per Jacoco, and also this line coverage is 100%, but mutation coverage is 17 of 19, right? What's the problem here? Why did we miss out? As we already spoke about it, and the tool will also say the same thing to us, saying that, hey, I ran all this. Wherever you see the dark green ones, I have tried to modify that particular set of code. And if it is green, it is passed. And if something is red, something I've tried to modify it and still your code passes. It doesn't change. So if you hover over this, it will say that I have changed the symbol from greater than to less than and all that. It has tried to modify all those 5 combinations in this one particular line, and your test passed, happily passed. It should have failed there, but it happily passed it. You can see the details of each of them down there, right? So what are the lines of code it changed and which got killed? If something survived, that's a problem for us. That's where it identifies the smell in the test as well, not just the code, not just the source code. Also, a test is validated and you have a strong code base there. So test is also a code. We should respect that and also have a good quality of test code there, right? So currently, what I have activated is these many mutators I have activated in my current project, this demo project. But you can choose to add anything you want from, there are like n number of mutators available for PIT alone, which gives you a lot of things like void mutators there, statement mutators there, decision making in also our arithmetic. There are a couple of things which you want to do plus minus or plus plus, all that it can take care of it. So based on a project and need, we can add that. So given that we have this, right? So let's quickly fix this and then see how it's taken. So I am at stage 2, right now. So what I'm gonna do is it's coming. So I'm going to git switch stage 3, which is the final stage of my demo. And in the stage 3, if I see, I have just fixed the test, right? I am adding a right proper assert and then calling the same statement. And in the source code, I have not modified anything else. It's the same thing, minus 1, right? Now I'm going to run my tests again. All right, I have all this tests written here. Now I'm gonna go and refresh this. So if the ones in red color, once I refresh, we can see the changes, right? So all this has been covered. So it tried to mutate this line of code, this arithmetic operations and decision making operators also, and then our tests have been killed. Our tests have been consistently failing if I change any one line of code in my source code. So this is now foolproof. Now, if new developer comes in, I am the owner of the source code. I have written something and gone. But tomorrow, since it is open, let's say if it's an open source code, and someone comes and changes the code, the curious developer is curious and tries to do his best, his or her best to write the code in TDD fashion. But of course, if the tools are right, they can happily code, and then they have the backbone support, like, okay, fine, the tool will guide us if we have missed something. So this is the main advantage I see, and this is why I'm a big fan of mutation testing, and why I'm promoting this everywhere, basically. Yeah. So this is what the demo is, right? So this is the source code which I walked through you. I'll also quickly walk through the setup. Setup is fairly easy. It is not trivial at all. So I'll quickly open. Yes, it is open source. Yes. So I'm going to open build.will. So I have also documented the setup in my GitHub repo. You can go and have a look. I'll also show you that in a while. So I have used Gradle to set up this. So you have a plugin for Gradle itself. I've used PIT version 1.5.2. Okay. So in this, if you see, I have used this tool. This plugin is available that you can use the plugin, and then that's all it is. You just add this one line, and then these dependencies will always obviously be that the unit test dependencies are already present. You don't have to do anything fancy regarding that. Once you have added this, you can do one thing is finalize this by Jacoco report and the PIT test. So what this will do is, if I run my Gradle test, Gradle W test, it will run the test. After running the test, it will run the Jacoco code coverage and the PIT. I have kept both for the demo purpose, but once we have the PIT inside, it also has the line coverage there. So you can have a choice of getting rid of Jacoco if you want, but it's on you and your project, which is like you can take a call on that. So if you add this, that's all right. So it will run after the test target is completed. This will be run after that. And these are the configuration which I have set up for PIT currently. As I said, right? So we say the test source and the main source, where are the source path. And then I have specified the plugin version. This is important while you use JUnit 5. For JUnit 4, they have a support for themselves. For JUnit 5, they have an external tool which supports this. But it's okay. We have the tools available. And the output format I have set up as XML right now, like HTML right now, but XML is also available. The mutators which I've used right now is a set of mutators which are available in the website. And number of threads I've kept as 4, and timestamp I've kept as false. If I keep it true, every time my test run, it will be timestamped and put in a different folder, so that every time I can know what is that, at which time what test failed, if you want to keep track of that. Yeah. So that's how easy is the setup for this using Gradle. There is also IntelliJ plugin available for this if you just want to do it in local, and if you are running this in a client project and client doesn't give you approval of adding this tool, maybe you can add in an IntelliJ plugin which will do that the same thing via IntelliJ, but it will be in your local, and you can analyze and then fix the things on yourself. It will not be shared. If it is in Gradle or command line, it will be shared across the project and it can be reused. So that's the call you'll have to take on your project basis. Okay. So I'll move on to the slides, back to slides. So once we have seen the demo right now. So let's see what are the things to consider while doing it, like putting the mutation testing in place. All right. So limit the number of mutation per classes. So if you see, right, as I mentioned, it takes the like a bytecode and tries to modify that. Since this is a small project, it is okay to give the whole project and then add as many mutators as I want. But if given a big set of project, there will be a lot of mutators. If we add a lot of mutators, it might take a lot of time to complete this test. And also the CPU usage will be high because it has to modify the source code in real time, right? That's a question from Deva. Is there any thumb rule of adding active mutators? There are no like specific thumb rules to add. I can recommend what I have added, but I will not say there's any thumb rule for that. Yes, that if you don't specify any mutators, it has its own set of mutators. It will do and run on its own. If at all you want to override, you can override and then only those particular mutators will run. Or else it will run a set of default mutators. All this is documented in the documentation. You can go through it. Yeah. So things to consider, right? Like now the second one will be choose the mutators, as you have just rightly asked Deva. So you have to choose the mutator based on the project requirement. So if the project is very complex in the logic of you have many void statements in that, then you'll have to use void statement mutator. And if you have many arithmetic operations in there, then you have to use ROR or maybe specific arithmetic operators which you want to use. So choose that on based on your project. So I'll give you the list of I'll show you where to look at that. You can have a look and then let me know. Like if you have still doubts, you can always get back to me. Yeah. So use filters to target only specific packages in the whole project, right? Let's say for the main business logic layer or the service layer, just target that at first. If you target the whole code base, you might end up in running this unit test a lot of unit test for a long time, and it will take a lot of your CPU usage as well. If you're running in the cloud, then you might also end up spending much. So the main, I would recommend to put this tool in only in the business layer where the main logic resides. At least that part should be totally tested and bug free. Other are just integrating layers, right? Like the intercontroller and other layers are just integrating with it. The service has the main business logic, but it has to be covered for sure. Okay. And then this is as I mentioned, is not recommended to run for each and every commit. So as this is taking a lot of time to compute, right? So this is a big task. So I would recommend that we can put this as a cron job in your CI. If you have a CI, put that as a cron job, or just run with the regression or smoke test, which runs only once a day, or maybe in a specific interval of time, let's say like 3 hours a day, or every 3 hours, or every 5 hours. Just don't run with all the every commit. Each and every commit, if you run, you're going to end up waiting for a long time to make the build complete. And yes, so based on how big your system you have to run the test, play around with the number of threads you have, right? That is optional again. If you don't specify, it will automatically take the number of CPUs you have in your system and then run accordingly. But if you want to optimize that, speed up that, and you really need to run everything in your project and still get the output, then you can use the number of threads as in one of the things to speed up the test coverage, the testing. Yeah, so that's me. So these are some references. So I have left the demo. Whatever I've shown you, it's there in this link. I have uploaded the slides also in the GeekNight website itself. Below the talk, you can see the slides and my also the code base over there. The links will be there. You can feel free to use it. The tool which I used was this PIT, as I mentioned. I'm just going to copy this and show you what are the list of coverages as I mentioned. And this is for Java, right? So if you go into this link, there are a lot of tools available for other frameworks and languages, like for Swift, Android, and also Rust. There are other tools available which you can use to integrate. I don't know how feasible or how good it is, but in Java world, it is very recommended and it's very good to use. I'll quickly show you this before I move on. Yeah. So if you see, as you asked, like Deva asked, I guess, for Maven you have the plugin. Yes, for Maven and command line, and also Gradle you have. So it is not recommended by them itself to run the command line because it takes a lot of configurations you will have to add and a lot of dependencies and libraries which you will have to add. It is recommended to use any tools like Maven or Gradle in order to serve better. I'll quickly show you the list of mutators. Sorry. List of mutators available, right? So as I mentioned, there are a lot of mutators. Like these number of mutators are available in the system. Right? For this tool, we have these mutators available. And there are these particular mutators which I mentioned here. So I will use something called ROR. Yes. So what this does is basically, if your original operator is this, it will try to modify with 5 different combinations for the same thing. If you don't want all the 5 combinations needed, you can use like specific mutators. You have your specific mutators also you have, which you can use, you can see and use. But I have used this as one of the mutator. If you see here in the code base, RR is the first mutator which I have used. Right, and all this there are math operator and void call and non-void methods and all are there. Also, there's one feature which is there, like if you want and if you run the test and then something comes up with something called java.util or java.lang, which is internal to Java, which has been invoked and not covered in your test, not to worry if that is an external library or something like that, which you think that you don't have to test. You can obviously come and say that avoid calls to these packages. You can also exclude classes, exclude tests in the same way, same fashion. Like I can show you a quick thing. Command line, right? If you go, yes, if you see target classes are there, right? So in the same way, you can also exclude method, exclude classes, and also test. The same things are available also in Gradle, Maven, everywhere. All the options are available. Just look out for the right page and then start with it. All right. Any other questions? Okay. If there are no other questions, then I would like to close my talk with that. So here is the form for feedback for the talk. Please scan this or use this link. I also post a link here so that you can.
That would be really helpful. What if people are attending via mobile?
Yeah. So I have posted the link in the Zoom chat as well. So please do leave a feedback there. I really appreciate any feedback you have for the presentation, for the tool, or for me. I really appreciate all of these. So please do mention that, and that's me. Thank you, folks. Thanks for the opportunity.
Hey, thank you so much, Vicky, for the amazing talk. I hope like you have shared all the informations by giving examples. I hope it's an informative talk. Thank you.
I'll just quickly do one thing. I'll show you where to find the links to the slides and this. So if you go to the talks, you can find it here, the slides and the code, it's here. You can also
Awesome.
go to the all editions, jump down to 82nd edition, you can find the same thing there. Yeah.
Awesome.
Okay. With that, I'll stop sharing my screen for wasting any time.
Cool.
Yes, also, please, you can, if you have any comments and if you don't feel like adding in the Google form, you can leave in the chat. I'll read it from there and take it from there. Okay. All right.
Cool. Okay. Thank you so much, Vicky, and thanks everyone for joining our GeekNight